Good morning, everybody. Just a quick lesson on solving equations using the distributive property. In our textbook, this is topic 2, lesson 3. And the focus here is using the distributive property as a tool. Okay. So the distributive property can help you to simplify expressions and make them easier to solve. Once we use the distributive property, then we're just going to go ahead and complete the solving of equation as we would any other. So I'm going to start with a pretty basic example. Okay. And the first example has 4 times the quantity A minus C is equal to AC plus 16 minus 6C. Couple things I notice here. I could definitely distribute this 4. There's another way I could do this as well, and I'm going to show it to you. I can also combine some like terms here and simplify things. Okay. So I'm going to distribute this, just since this is the focus of this lesson, and show it this way the first. 4 times 8 is 32 minus 4C equals 8C plus 16 minus 6C. Now I'm going to leave some space over here in my notebook because I'm going to do this a different way in a moment. Okay. Now I notice that I have some like terms. So those can be combined. So now I have 32 minus 4C equals, 8C minus 6C would be 2C plus 16. Okay. Now I have a negative with a variable, which isn't the end of the world, but I would like to not have it. So I'm going to add 4C to each side. And I have 32 equals 6C plus 16. And I'm going to go ahead and make some more room for us on this. Hold on for me just a moment. There we go. Okay, and then if I combine like terms again, I get subtract 16 from both sides. That is not going to work. So I am going to move this down. I apologize for this glitch. Now, here I have 16 equals 6C. Okay. 6 is being multiplied to C. The inverse operation is to divide by 6. So C has a value of 8/3, or that could be 2 2/3. Okay, I do not like the decimal equivalent of this because it is an estimation. It repeats. So the fraction and the mixed number are better answers for this. Now, I did want to show you this an alternative way. Okay. The alternative way is to use distributive property to save us a step later on. So if I had 8 minus C equals 8C plus 16 minus 6C, same problem, and I just go ahead and combine the like terms from the beginning, I could maybe save myself a couple steps. Notice that it doesn't matter in which order, whether I combine the like terms first or whether I distribute first. Okay, so whatever it looks like it's going to make it cleaner for you, those are the steps and the orders I want you to take. All right. Now I have another example, and this one is using distributive property truly as a tool. Okay. Here we have a fraction with our variable. Okay. And in this case, we're going to have to get rid of this fraction. I can do that from the very beginning. If at any point in an equation I multiply everything inside the equation, both sides equally, by that denominator, the fraction is neutralized, to use a wonderful student term. Because 5 times 4/5 just leaves me 4m. 5 times 4, 20. 5 times 12, 60. Okay. We've now taken this down to a very simple two-step equation where I can isolate the variable, use inverse operations for each step, okay. Oops. There we go. Give you the rest of the view of that. Notice, I needed to move that positive 20. The inverse operation would be a negative 20. I needed to move the fact that 4 times m, so dividing by 4 is the inverse operation. Okay. Again, you have choices. There is more than one way to do an equation. I could have combined these constants before I did anything else and had 4/5 m equals 8. I still would have needed to either multiply by the reciprocal or at least by the denominator. So if I do both of these times 5, I now have 4m equals 40, m equals 10. So please notice that as we are doing these equations, there is more than one way, but the rules have to be obeyed. And distributive property can be a tool that you choose to use to make your life simpler, or it can be a little bit forced to simplify the equation and be able to move forward. Okay. Now there's one more I'd like to go over with you, and it is a story. This is a story of a guy who works in a bakery. Okay. And the gentleman who works in the bakery is having a struggle because he cannot remember how much sugar to put in the filling. Okay, so he's making cakes. He's going to make 8 cakes. He doesn't know how much sugar for filling. Okay. He does know that he needs 1 1/4 cups for the cake part, not the filling. 1 1/4 cups of sugar. But that's not the filling part. Okay. And he does know that he needs a total of 12 cups of sugar. Okay. So that's what the dilemma this poor employee is facing. Okay. Well, let's think about it. We know we have a total of 12 cups of sugar. And that total is made up of, okay, 8 cakes. And the 8 cakes have 1 1/4 cup plus F for filling. I don't know how much sugar. Okay. So this is the known amount, and this is the unknown amount for filling. Now, look what happens here. By using distributive property, we can get somewhere. So 12 equals 8 times, well, the best thing to do here is make this an improper fraction. They're a lot easier to deal with. Well, what's 8 times 5/4? Go over on the side and do the multiplication. 8 times 5/4. 40/4 or 10. So now we have that 12 equals 10 plus 8F, because this had to be distributed. Okay. Well, now we can start to isolate the variable. 2 is equal to 8F. 8 times F, the inverse operation. So this says that each batch of filling is going to take 1/4 cup of sugar. Okay, if it's a fruit filling or something that's already sweet, that's all the sugar it's going to need. Notice how distributive property helped in that situation and how it came out of the story itself. This particular problem is also on pages 52 and 53 of your textbook if you wanted to look at it again.